Welcome, Chapter 7. We're going to start doing design on profiles, a new thing in Civil 3D we're learning. Designing profiles vertically using design profiles in the vertical, and that is the main focus of this chapter. It is Chapter 7, and we'll begin by downloading our files here in Moodle, as usual. There are 14 of them, 7 of them complete, 7 of them not. That was Chapter 8. Should be similar, maybe 2 more here. 18 of them total, 9 complete, 9 for you to do. So with no further ado, let's begin. So we have Chapter 9 here, or Chapter 7, excuse me. We have our first file, surface profile, but let's talk about the beginning of this chapter just a little bit, and open up your book to page 131. And we'll talk a little bit about profiles just to start this off. So profile view is going to go hand in hand with our alignments, and they are designing in the vertical with respect to our alignments. So how would a couple things going on, how steep is the terrain we're going to be designing on or mapping, or how will it be like to travel across those paths on those in the vertical? Will the terrain be too steep to drive on? Will it change from one end to another? Are there valleys and crests to go over? So that's the kind of stuff we're going to be answering. And from the Chapter 4, modeling existing terrain surfaces, we learned a lot about how existing ground surfaces can be used to analyze the shape of something we might design. These profiles now are going to come in hand with those surfaces that we did in Chapter 4, and we're going to design on top of those surfaces. We're going to use our existing ground to make inferences and design, starting using the existing ground as our baseline, making surface profiles. And in this chapter, we're going to have 5 general areas. We're going to create surface profiles, as I just mentioned. Then we're going to go on to display profiles in a profile view. You can't have a profile without a profile view to put it on. We're going to do design profiles next after that to design on our surface profiles, proposed or new ground, theoretically, depending on where the alignment is. Then we're going to learn how to edit profiles a little bit in the graphical and deeper edits. And lastly, we're going to apply some design checks in criteria files similar to how we did on alignments in Chapter 5. Certain things that hold design standards on profile geometries that are best practices and setups according to different agencies and standards that have been shown to work for things like transportation and water and various other things. So with that being said, let's move on to the first exercise on page 132 here. We're going to learn about creating surface profiles, which is quite easy, but there's a lot of steps to it, and we're going to dive into it now. So start with opening your surface profile DWG file, and I'm once again, of course, in Civil 3D 2022, so I can keep using a more modern version. We'll see how it goes. I haven't had too many problems as of yet. And we're going to start by going into this file and learning how to make our first surface profile. So there's a few ways you can get to the profiles, and one way we're going to learn quickly here is you click on the Jordan center line alignment, like we've been doing a lot in Chapter 6 and Chapter 5. So keep in mind we have our surface back with us now in this site development. So I clicked on it. We have a tin surface, a triangular irregular network surface. Surface and an alignment are 2 essential things to create profiles, okay? Into our profile views. So we're going to click Jordan chord alignment first. Our contextual ribbon comes up of various options. Let's go over them real quick again. We got a lot of what we learned in Chapter 6 from alignments are going to be similar with profiles later on. We'll find out labels, tables, tags, different inquiry tools and isolation tools, and bring to front and back, okay, to manipulate and find information about whatever Civil 3D object. Our modify tools, once again, analyze tools of alignment, and our launch pad. These are the big ones here we're going to start on right now. So we click this alignment. We have options here to do a surface profile, profile view, some other things, make different alignments based off of this center alignment, which is awesome. Keep in mind, if I hit escape and back out of that, in the home tab, most of my Civil 3D things here and these palettes, all my palettes around, and my main Civil 3D commands are in here to create things. Ground data and survey data, design data. If you pull this down, there's more options here. These are some of our big heavy hitters, and different views, profile views, sample lines, and section views. These are home base for creating the vast majority of anything we'll need for Civil 3D. Okay, right next to our AutoCAD areas. Our most common AutoCAD commands are the draw ones, the modify ones, all in here in this panel, and the layers, manipulating layers and various things around layers, and also copy and paste in the clipboard. That is why they're on the home tab, because these are the most used AutoCAD commands statistically and scientifically shown, and these are your most used Civil 3D commands to create anything main Civil 3D objects. So just keep that in mind. Let's pick the Jordan Court centerline alignment, and let's go to the contextual ribbon, and we'll say create profile, create surface profile right here. Give it a second, and we'll verify Jordan Court is indeed selected on our only surface. So you need an alignment in the surface to create a surface profile initially right here to create profile from surface. Let's add it. It doesn't want us to do anything under this, any different, but let's take a quick look. My profile list comes up. This will, in my tool space, eventually populate under, it's said given alignment, Jordan Court. Its data source is EG, which is the surface. Its type, it's going to be surface profile. You can tell by this jaggedness here. Okay, we're going to hit OK. Now in the prospector, we made this surface profile, but we have made no view yet. So you can indeed make a profile without the view. I'm a little mistaken in saying that, but you can't see it anywhere. We need the profile view to visualize it, okay? Here is the profile I just made, e.g. surface 1, as it says in the book in step 5, listed under profiles. There's a small orange triangle next to it, as you see, and now in Jordan Court. So this indicates that there are objects in the drawing that are dependent on this alignment. This is dependent on something else, which is an alignment in this case. It's following under this tree. Keep that in mind. It's kind of a sneaky thing in Civil 3D. In this case, the dependent object is this profile we just created. So let's right click it this way, as it says, and click properties. This is a little different way of doing how I would do a profile, but I do like trying different. As in Civil 3D, we can get to doing things multiple ways by clicking, going to different areas of our screen and tool space, our ribbon, or just right clicking. Okay, and now we're in here in our profile properties of this EG surface. In the information tab of the profile properties dialog box, we're looking at it here. Let's change this to Jordan Court EGCL, and we'll click OK. So Prospector shows that the profile has been created. I still have nothing graphically to show. That's okay for now. To display this graphical representation of the profile, we need a profile view to put it on. So profiles are basically, they follow the alignment as much as you want it to, but they literally flip it in the Z or elevation dimension, flip it 90 degrees to the horizon. That's what a profile view is. It's just in the Z dimension, but it does follow, you'll see a XY graph. So we will take to the next section to make our first view. That's just showing us a little bit about making our first. I wouldn't exactly always do it that way. So we're in our second file, profile view, and on page 133. And a profile view is made to display a profile, okay? So a profile is just a grid system that contains stations in the X direction, that's a big one, and elevations in the Y direction. We'll see that in a second. So if we go to one completed here, we have stations going start to finish upwards. We don't really have a good grid here, but this is 0, 0, and it's going upwards in this direction. And then the elevations in the Y direction, starting low, going higher. And these are generally, you can see it says elevation there. Depending on the profile view style is how it appears. It gets higher. Oh, here's our stationing on top actually. -100, here's 0, here's where the alignment starts. No surprise, that's where our profile starts. That's usually the case with these. They go together, Jordan Court profile. So the station in the X, the elevation in the Y. Go back to profile view drawing. Let's go back to clicking the Jordan Court alignment. And then we'll click profile view in the contextual tab here. So we have our alignment and our launchpad options here. We're going to click it this way, profile view, to create one. We already had our surface profile created, so this one's ready to go. General, say yes to Jordan Court. And it doesn't want us to change much. So let's just accept all this stuff. The major grid's 10. This is the default setting it goes to, which is fine. Let's just hit, in this case, create profile view. We're just going to do this quickly. This is just our intro to doing this. And it says somewhere, select profile view origin. I always watch your command bar to see what it's trying to tell you if you don't know what's going on. And it also has a contextual prompt up here saying select profile view origin. Let's click out there. It made a profile of this entire alignment, Jordan Court. Here it is. There's another way to do that too. We could go this route. We can say, once again, create surface profile. We had already been here. We had already set this up. We can, instead of leaving this by hitting OK, we can say draw in profile view, and it continues on to this prompt we were just on. We can skip a step. So section 7.1 and 7.2, I wouldn't do it the way it did. I would just do it all at once. So I just made the same exact thing again in one step. So that's the end of 7.2. Let's move to 7.3, and we're going to learn a little bit more of terrain along Jordan Court to design on. So we're going to do our first design profile, and it left us some handy little nodes here to pick and stuff, which usually don't have that. You got to do this more manually, but this is just for instructional purposes to speed it up. So this, as the surface profile shows, we look at the current path. It might not be suitable for driving. Maybe this is too much of a steepness here. Maybe this goes down 10% an average grade. We'll find out when we do a design profile. That would be, you know, most urban roads too steep, not safe enough, not desirable for most design standards. Interstate highways, whatever it might be. It depends on where you are, what municipality you're designing under. You might have to follow their standards. That's stuff for anywhere in the United States or the world, depending if it's English or metric units. You just have to go by their standards a lot of times. So this is, we might see what this grade is and say it's too steep. But essentially, we make this kind of profile, this new profile, we can think of it as a design profile or a layout profile on top of this surface profile. It's going to be design ground ideal, and it's going to reflect to the center line of this alignment of road. Could be a canal, could be something else like a pipe network underground, but this is a road. So in this case, we're going to design along the center line of the road, our ideal road over it, a design or layout profile. Now, like alignments, profiles are interconnected. If we go to a step up, we're going to make this one here, and they have lines in between them, like so, and these are tangent, and they have curves, like in our alignments. They're actually called vertical curves because they're purely in the vertical, because this is only in the Z dimension. So we're in the, essentially, Y in the Z dimension, we're flipped 90 degrees from the X dimension, so to speak. I might have said that wrong, but think of this as the horizontal. This is the vertical. They go hand in hand. This is just the alignment rotated 90 degrees on the cube up here, and that's the profile. We have curves in here that are tangent with PIs here at the theoretical where it would meet if there was no curve there. We have a point of vertical, a PVC, point of vertical curvature, a point of PVT, point of vertical tangency, where it turns back to a line of tangency again. So we have different types of curves. So we'll talk about those in a moment. We'll talk about the different types of curves in a minute and what's on a profile once again. So let's click on back into our design profile DWG. Let's click on one of the grid lines to start talking about the profile view. This one is the Jordan Court 8-1. I could have named it a little better and just called it Jordan Court. One of the big things as these populate, it's really, under alignments, it pays to get very surgical with naming these correctly. So this one, this profile view here, it says EG center line, existing ground center line. I might name this correspondingly, potentially. Whatever you got to do to keep these organized. They can get very unorganized very quickly, depending on how many you have in a site, and it helps to keep this tree organized. So with that being said, let's click once again one of the grid lines on this profile view, and let's look for the profile creation tools and the contextual ribbon that comes up. Here they are, right here. You can also right click, which isn't an option there, so let's just use profile creation tools. And you can also go up here. If you start in the home tab, you can go home tab, create design, civil 3D stuff. You can go here as well, profile creation tools. Then you just have to select the profile view. We did it the opposite way. We selected the profile view first, the noun, and then we got the verbs, the actions. Now we select the verb first, create profile view, and then the noun. So it's just a different way of going about it, one way over the other. Now we're creating our profile view, or our profile, We're going to call this one. So this one's going to be similarly named Jordan Court, but FGCL, finished grade at centerline, not existing grade at centerline. And we're going to pick the profile style set to design profile. That's how the profile itself looks, the line we're going to draw. In the label set, we're going to say at this time is no labels. We'll later learn about those more. Click OK. Now the profile layout tools toolbar comes in. It's how we design the geometry. Let's bring that down here. We can do a lot of things in here to draw it in, to design it, to add vertices, delete vertices, to move vertices, to draw lines in between of different floating and moving, to draw the circular curves, parabolic vertical curves, circular vertical curves that are even. You have some asymmetric parabolic curves that are uneven, which it kind of talks about a little bit on page 135. So circular curve is our most generic one. It's a vertical curve that has a constant radius. It's somewhat common. Depends which design, how you're designing it. A parabolic curve is more parabolic shaped. So remember parabolas have a little bit more of an aggressive shape in some ways. They might look a little more like this. Depending on how tight the vertical curve is, these ones are a little wider. If we look up parabola online and just look at this, parabola has a slightly different shape. This is a pretty extreme shape. It would be possibly this is a little more flattened parabola. A more parabolic shape, which isn't circular. It has a different mathematical equation that makes it. So we have a parabolic shape for our curve tops and bottoms, or crests and sags. And we have a circular, which is constant. Parabola is not. And then we also have options to make asymmetric parabolas. So they have a little bit different parabola on one end that transitions to a different one. So it's like a kind of a broken back curve. So if we typed in here, so a parabola cannot never be asymmetrical, but mathematically speaking, but in general it's two parabolas. So how would we best see that on Civil 3D? There's a best fit one. It makes a circular curve or a three-point curve here based on some points, just fits it through its best fit. And this wouldn't be the best spot for this. This is an asymmetrical vertical curve and a sag function, a valley, a bottom. So this is a sag vertical curve. So you can see this side's a little bit sharper than this side. It's not quite even across the whole curve. That's an asymmetric parabolic curve or setup. These are all sag curves. Sag vertical curve, sag because they're on the bottom valley. That's one distinguishing thing. This is a crest curve. It's on the top, or a hill. That's where we design for the top of a feature. So that's the difference between crest and sag. And we talked a little bit about different types of curves. So let's create this bad boy. Let's get on with it. And we're going to go to this area of the creation, and we're going to say draw tangents with curves. Okay. And it wants us to press and hold the shift key and then right click, and it wants us to uncheck all the other boxes except for center. Well, we can also go to our running O-snaps. Let's check our running O-snaps here in our tray. Let's turn everything off except for center. So we only go to the center for a little while. It's still ready to pick my start point of my profile I'm about to make. So now it's only going to snap to the center. See how I have my center snap? That's all I want, not any others. So see how it's making curves as I pick my PIs? These are my PIs. That's where they theoretically, the curves tangents would meet and intersect. But they're making curves there instead of just straight jagged lines. And that's what I want to start. And in my settings, this has already been set to what type of default curve, which is great. I think it might be around 100. I'll hit enter when I get to my last one, G. Enter. I have my first design profile with curves, PIs, all kinds of things. And that's what it looks like there. So we have a PVI at each point. So say on F here, that's a PVI. And it has grips to slide this direction with this tangent, or slide this direction with this tangent, to change my PI, my PVC, point of vertical, PVC, point of vertical curvature, and the end point, the PVT, the point of vertical tangency, where it goes back to tangency after the curve. So we can have asymmetric curves, circular curves, we can have parabolic curves in here. Right now we're just going to take whatever curve it's given us. And we've created our first profile. So on to 7.4. So we're going to start editing profiles, and I'm going to go to graphical editing 7.4 here. As we learned in chapter 5, it's good to lay out a rough version of stuff, which we kind of did here, okay? And we got it close. In this case, a lot of times profiles, we might want to draw it close to existing ground. In this case, because we're trying to use the existing ground as best we can. In this case, the design of the center line of the road is below the existing. That means we've got to cut the earth out there. In this condition, not much of the conditions, just briefly right here, we're slightly above the red, the red existing ground and the design center line over the center line of the existing ground. This would be a fill scenario. We got to bring in new material to fill here. This is mostly all in a cut scenario, so we have to cut a ton of earth to get this road in here. So a lot of times our first initial swath, we might add some curves in, get them working somewhat right graphically, not to have too much cut, and we're just going to do our best, check our grades. So we're doing preliminary design. One thing we don't want to have a bunch of earth to remove, quite simply because it's very expensive and not good smart design. So that's a lot of things we're thinking about in the initial profile as we lay it out to match the existing ground where we can, where it makes sense. So into 7.4, we're going to start in the file called graphical editing, and we're going to click the blue Jordan Court FGCL profile to display its grips. So there we go. We see all of its grips in there. We're going to learn about graphical grip editing first. And let's go to the A1, A2 area. And we're going to start by clicking the triangular grip located right in the center. We're just going to grip it from here and move it to here. Hover near the circle to get your circular O-snap. Remember, you set these to only show center. So you might have to turn some other things on later if you need to snap to endpoints and midpoints and nodes. So that was one grip edit. That's all we did there. We're going to do the next grip edit to B1 to B2. So it wants us to do a different grip edit here, I do believe. We're going to grab this triangle here to the right. We're going to grip it and move it all the way to the center of this, more to the top of the hill. So this is what you would call a crest curve, vertical curve. This is a sag vertical curve. It's on the valley bottom. This is at the top. You have different things to be concerned about as you're driving along. Say this is a road. You have a sight distance. You have a blind edge here. You also have, you ever done ski jumps before? You go so fast on these, you fly right off the top. So you a lot of times have to have certain vertical curves to control that, to control your design speed so you don't literally just shoot off the top. That's a big thing with transportation. So we'll talk about that in a bit. If we go to page 138, we'll move to C1. Let's click our design profile again. In this case, we're going to take the middle of this tangent line. We also have a square grip there. We can move those. So a lot of times you might do some drafting with circles and polylines, however you need to do to make a node to snap to. These ones were just happen to be given to us, which is just for instructional ease. I can move that to the center. I'm starting to shore up this design profile to not have so much cut. Cut meaning the existing earth is well above the design earth. That means a lot of the existing earth is going to have to be cut out and removed and excavated, which is very expensive. So we'll move to D. We'll move that triangular grip. Essentially, we're just going to move that up to the center of this. If you hover near the circle, it'll do that. E, it wants us to go near E1. So it was near here, but we're going to move it right. Oop. Let's give this a try here. There we go. So this is a little different. I don't know if I did it 100% right, but I basically moved we got D2's PI correct here. Okay. I'm actually going to backpedal one. I showed you how to move some things, but let's go back a couple, hit Control Z a few times. And I'm going to go back to my D1, D2 move. And let's just see different things we could do with these as we move them along. And you have to hit Control Z or undo a few times, oftentimes with CAD, because it accumulates so many commands. So this one, C2 was moved Let's start again by moving the square grip in C2 to C1, or excuse me, back to C2. Let's get this moved. Just different ways to move things around. That passes through there. Let's try to move this amongst the center. So it means it passes through here. We're passing through here. These, I can't pick the exact nodes, but I can pick the level they pass through. And then on E1, E2, I can make this pass through E2 instead by moving it over here. I don't think I got it perfectly well. So let me do it one more time. You don't have to get this perfect. This is just showing different ways to move this. My C2 here, this should have been closer to here. Not sure why it's not. I got the B1. I moved it from B1 to B2 on this level, the actual PI of that vertical curve. Yeah, that's correct. I moved the triangle grip to the right. Or unless I was supposed to do this. But no matter. We'll try it one more time. I'm going to take this square grip, slide it to this one. And then on D, it's a little off of what the book shows. So C2 is up here. You sometimes have to move these in very strategic ways, so I'm kind of getting it. C2, it still runs through it. D2, it's still relatively close. And then E1 to E2, we're going to move the circular grip at the center of E1, which it is not anymore, honestly. We'll get it relatively close. So that's good enough. We'll move on to part 5. That's just showing you how to move some of those grips as best you can graphically. Exercise 7.5. Before we do that, it's going to say something about profile locking. So I've clicked my profile and I'll go to profile properties, or you can go up here. Similar, once you select your profile, you have contextual ribbons for said profile. Slightly different than alignment, but very similar. Profile properties here. And we have what we call profile locking. So you may wonder what happens to a profile when alignment is added. Well, the surface profiles, they change. They update to match the new path of the alignment that it's associated with. So for design profiles, the answer is a little more complicated due to a feature called profile locking. So it's in the feature tab. I said it's right here. And with this feature, you can essentially link the profile geometry with the alignment geometry, and Civil 3D will then attempt to keep both features aligned. So this would keep them aligned with each other. It's something that doesn't get used too often. So the profile geometry points essentially would anchor with the alignment geometry points. So for example, this top of crest here would lock somewhere along the stationing, which would be, whatever this station is. If we hover in here, station 8 plus 52, that would lock in place with wherever station 8 plus 52 is here. It would allow, you would have to remain, they would be locked positionally somewhat between each other. So it would almost be like there's profile information in here that can't be touched, that links this position with this position. So it's just a way to interlink them. I'm going to turn it off for now. Go the other direction by right clicking, go to profile properties, profile locking, it's off. Okay, I'm just making sure. So back to 7.5. Let's click back on our Jordan Court FGCL profile. And in this case, we could right click and go to edit geometry this way. Or we could go up here and go to geometry editor. We'll get our profile layout tools. Let's pull them down. In this case, we're going to do some deeper editing. And we're just going to add a PI to start. We're going to go by this adds a PI, this deletes one. Add PI. It says where's the point for this new PI? We're simply only going to add a PI to this center point. That's all we did there. So we got that. It's pretty minor, but we added a point of intersection. Now let's say delete PI while that's still going. And let's see where it has us go. We're just going to go to circle B and delete that said PI right here. It's kind of a nuisance one. It's just extra stuff. We should just have one tangent right here running all the way down. This is kind of an unneeded curve, vertical curve basically. So we're going to delete it. We deleted it out. And now I have a straight tangent section in this part of the profile, which is ideal. The next one, we're going to go to insert PVI's points of vertical intersections in the tabular function. Click that. So now we can do our different vertical curves here. Okay. Let me just start by going into 10 plus 19 plus 10 for the station, and 174 for the elevation. I hit enter to create a new line. Let's enter 21 plus 55 for that station. Tab doesn't work, so I'm just going to left click. And let's do 173.5. We're probably on like the East Coast or something. It's pretty light. We'll hit OK, or Enter, excuse me. And now let's hit OK. So that tightened up our curves right here. So that was in this general area. It literally moved our curve a little bit. Okay, right there. So essentially, if I hover in here, you can see what comes up on the stationing. So essentially, I just made a PVI at a certain elevation here. It's at 19 plus 10, and then made one here at D 21 plus 55, and it made it at these exact locations. So if I hover here, it's at the elevation that I said, 173.5. I'm pretty close. If you hover, you can get kind of close just to check it as one way. So that's essentially what I made, was these two here through the tabular way. Now we're going to do another way. I hit escape one too many times. If you end up doing that, click your profile again. And this time, instead of going up here, right click and go to edit profile geometry. It brings up the same layout tools again. This time we're going to go to vertical curves here. We're going to go to more free vertical curves, and we're going to pick the free vertical parabola point of vertical intersection PVI based. Okay, so bear with me for a second. Now it's asking, pick a point near PVI or a curve to add a curve. It's a little confusing. It wants us in the instructions to click in the circle marked C. So let's just click in the center of this circle. That'll be our PVI. We have established its PVI. So we want our curve length and my contextual ribbon here. So let's type that. Or actually, 150 is its default, and that's what we'll accept. So whatever's in the carets, we'll accept that. The K value, we could use that, or the pass-through. There's different ways to do this, but we're going to stick with this. We'll hit enter to accept the 150. And now it's saying another curve. Let's pick at the circle marked D. And in this one, let's type 200. So there we added two curves in various directions with a different method using the more free vertical curves, free vertical parabola based. So we picked our PI, which was essentially right where we got that established. So you can see the criticalness of picking these PIs to guide your curves from there. And then we made yet another one here on D, but we made a 150 foot length one and a 200 foot one. So if we go here in this area, or I meant in this area here, in the grid view, we can see their length. So this is a crest curve. If we keep selecting these, it'll highlight it. So the one with the icon that shows up, we can see we made a 150 foot profile curve length, and this one's a 200 foot one. It highlights when I select it. You can also edit them here. It lengthens. So multiple ways. We'll jump into page 142, editing a profile using profile grid view, which I just did here. All right. So let's go into profile grid view just to continue on. And we're going to go back to our Jordan FGCL profile again. And we can pick the geometry editor once again, or right click and edit profile geometry this way. So in the newer versions of Civil 3D, the icon has changed a little bit. It looks like this, but it's called profile grid view. It brings up the panorama into our event viewer, so we can do some deep graphical editing. So we did some grip editing. We did some tabular editing, saying exactly where I want this, exactly where I want that, which if you're trying to mimic some old plans, tabular might be the way to go. If you're making fresh, brand new graphical, and grips might be the way to go with some drafting to snap to. If you're trying to do the final dial in, you're probably going to come to this grid view to your final dial in, basically. So some things got to give. Maybe you want to keep them on even stations. Maybe you want to keep them on even to minimum curve lengths or K values. Now, a K value is the amount, the aggressiveness of the vertical curve, basically, how sharp it is. So the smaller the K value, the sharper the curve. So this first one, if we change this K value to 10, it gets tiny. It's almost like a wedge. So that's what K value is. It's the amount of change of the curve, how quickly, which corresponds to a radius and corresponds to a curve length. So the length is from here to here along the curve. The radius is obviously how big a circle it is to its center, or how long a distance to its circular center. And the K value is a ratio of that in some way or another. So anyway, I'm going to hit Control Z to undo that. That's just talking about K value a little bit, which is important to know a little bit about curve design. So we're in our grid view here. We're going to go to item 3, which is here, and we're going to change one item to 270. So in this case, we're going for jockeying position on making these even stations to our PVIs, our center of our curves. That's fine. And the PVI value of an elevation of this same one, we're going to change this to an even elevation. So this is where you're going to do your fine tuning of your profile view, getting it to even stations, even elevations, and various things. So it wants us to change a few more things. Item 4 wants us to change this to 855 and even 5-foot stationing. I can tell you, for example, and the elevation to something a little more even, that certain highway agencies, like federal highway agencies, a lot of times like PVIs and also in the horizontal and alignments to be in even stationings a lot of times. That's some of their design standards. So it depends who you're working for. These things are important. Sometimes they're not. So if a small private developer, they could maybe care less about some of this stuff, but it's nice to have neat plans too, so you can get around and the contractor can understand them if there's a road or a canal or pipe network being built. So that's all we did there. We just edited some things. So these curves were slightly moved in the elevation and stations. So stations in the X, remember, elevations in the Y. We just dialed them in tight to exactly where we wanted on this grid view. That's basically all for 7.6. So there's good design practices. We've been learning how to do them in many different ways, graphically, tabularly, grid view. We didn't use too much the profile layout parameters. We can really get into one area at a time here on these, which we did with alignments, but we won't do here as much. So sometimes we showed a lot of times we round off to the nearest whole numbers, whether it's 10s or 5s. A contractor or surveyor that's staking these out in the real world or building them, it's easier them to keep track of even numbers and stuff. So if they have all these extra hundredths of a decimal, it might not add up to a lot, but it's a lot harder to look at and interpret and add and subtract and stuff. So some of the beauty of this is good design practice to put a lot of this stuff at even things when you can. And as we're going to learn at the end of this chapter, how to do the final edits to make sure our design criteria is going to be followed. So let's move into part 7 of this chapter, profile component level editing. We're going to pick the Jordan Court profile. We're going to try something different, yet another editing tool. Let's pick it again, and I'm going to hit Geometry Editor this way. We're going to learn a little bit about this editing tool, which I just brought up, the profile layout parameters, which we did similarly in alignments. It comes up blank right away, so don't be alarmed. But we're going to pick in here, we're going to pick select PI, and we're going to go to the lowest point of this profile, which is right here. It's the lowest curve, because we can tell because the elevation is the lowest here. It goes from lowest to highest as we go up. Let's pick near it somewhere. It doesn't have to be perfect. and it's saying a lot of information. So the headlight distance that we can see coming into this curve, the grade coming in, this is going downhill as we go up station, we're going downhill into a valley, into a seg curve, and then the grade out is up 4.5% in grade. Okay, the PVI station is literally the station here in the x-axis. The PVI elevation, which is here, that is this elevation in the y-axis. So see where my crosshairs crisscross over here? That's literally that elevation. A lot of information. And then the low point of the station is here of the curve, which is up. The low point is where the curve is at its lowest, which is probably right about here. And in the curve length, it has all this stuff. So we're just going to change one thing. We're going to change the profile curve length, this method, 275, instead of that oddball number. It shrunk it just a little bit. It shrunk it evenly on both sides in a way. So now we have some more even stuff. The profile curve length, it depends on what our parameters are. We try to mess with this stuff as best we can. Something's usually got to give, and mathematically, something's going to be an odd integer or decimal fraction. You can get a couple of two out of three things, let's say, to even numbers, but one might have to be at an even, a not even decimal place. So you do the best you can there without, losing your mind on the math of these curves. So that's another tool for your tool belt. We'll move into design checks and criteria files, which is file 8. So we learned about these in chapter 5. Basically, check sets and criteria files. They help you check your design on the fly to check, find any large errors or design flaws of too tight or too big a radius is. They can vary from place to place, different states, different municipalities, different countries. They can vary from design type to design type. So if it's for highways, if it's for residential slow roads, if it's for a mountain road, the design type to design type also changes. So it lets us, the task with a CAD manager is set up these check sets to quickly check our designs to see where the red flags are. And they can be helpful because a lot of those standards are driven by departments of transportations, planning commissions of cities, government entities, federal highway government entities. I've worked for all three of them at some point or another, and they all have slightly different standards. So don't be relying on these things 100%, but they get you flagging errors that human eyes don't always catch easily. So if they're set up well, they catch things. These criteria files and check sets, and understanding your design principles better is a must to not let them think for you, but they do help you as an extra tool to your tool belt. So they're just a way of making sure you apply what you hopefully already know, and not a substitute just to not think. So they help, and I wouldn't use them, as this chapter progresses more towards the end as we're doing. So let's start by clicking on, once again, the Jordan Court FGCL profile as we've been getting used to, and then let's click Profile Properties up here, or we could do it through the right-click way. Also, let's not forget you can do some of this stuff in Tool Space. If we go through alignments, forget about our file tree as we learn about it. Jordan Court alignment. Our profiles populate under here. Here's our existing ground one. Here's our finished ground design one. Here's our profile view we're editing on. It probably should have a better name, but it's just Jordan Court for now. We could honestly rename it if we wanted to. That would be ideal. It has Jordan Court corresponds with the alignment name. That's good practice. And we have but different names for our profiles on it. You can also right click and go to properties here. Similar. It'll bring up the same dialog box. Profile properties. At this point, we're going to go to the design criteria tab. Similar to alignments, it's going to apply some design criterion to help us better check our profile. And we're going to say use design-based criteria. We're going to say use design check set. In this case, we want to select the subdivision one. We'll say okay. Whatever is in there, we can go to edit and see what's inside of it. Eric Chappell, that wrote this book did it. There's some design checks in here for lines and curves. Curve length must be greater than 3 times design speed. For example, if the design speed is 60 miles an hour, the curve length must be at least 3 times that, so 180 plus. Maximum curve length, drainage, and applies to both the crest and sag curves. Tangent, there's a second check. Tangent must be between 0.5 and 0.5% grade. So minimum grade is 0.5. It's almost flat as a pancake. And 5 is maximum grade. That's starting to get kind of steep in a residential road. So there's two main design checks checking for vertical curves and minimum maximum grades. Those are helpful. Lines, similar. So if we hit cancel, I went inside of this subdivision design check set to see what's in it. Just to show you, we'll hit OK. Give it a second. It should find some errors. It did. Right here on figure 7.10 on page 145. Here's the warnings symbols basically indicating there's some design check set violations on our curve for the subdivision design standards. So let's hover on the one on the left first. Let's just hover on it. It says what it is. Design checks violated. Tangent grade must be between a minimum of 0.5%, not even 1%, and 5. So it's probably too shallow. It's too flat. Essentially, I'm just going to do a quick edit, sloppily or whatever. I'm going to move this PI up just to appease this warning, and it's gone because now I have a grade that is larger than, we're just doing the graphic. We're going to learn about labels more later. You would see a grade here that would change with it. You could actually see the grade graphically. It's not as steep as 0.5 or flat, or it's not as steep as 5. So if I went up this high, it's probably going to get too steep pretty soon. Interesting, hasn't done it yet. Might need to rerun it. There it goes. Too steep, too steep, too sharp of a curve. So that's over 5%. I'm going to go back a couple. Control Z is my friend again. My old friend, Control Z. So basically it's too flat there. The design check's flagged. Let me just move this PI of the vertical curve a little bit. It's gone. So let's hover over this warning symbol. Let's get a little closer. Sometimes you gotta get, it depends how zoomed in. Design checks violated. Curve length must be 3 times the design speed. So my curve here is almost inevitably too short. The design speed's whatever speed it is. I didn't look at that one, but it's definitely looks too small. So what are we going to do there? Let's make it bigger. How can we do that? There's a few ways. We can just move this out a little bit. This grip, that made the curve bigger. Without telling it too much what it was, I made this curve way bigger. So that's gone. Without getting too pressing, we have one more design check out there. Might went a little too steep on that one. And that's okay. I'm not going to go in too much further, but let's hover on this one. So I made that too steep on that side. Let's bring that down. Let's bring this one up a little. Anyway, that is good enough for now. I got 2 of them gone. I'm not going to fight the other one much longer. We'll move on to the last area of this chapter, design criteria file. So we edit that. So same as we did with alignments, you can assign a design criteria file to a profile 2. Gives a general behavior within the criteria file. So as the checks, they display warning symbols, tell you where the parameters are not met of your profile, similar to alignments over here. They work similar. So yet again, let's click this Jordan Court FGCL profile, and we'll select profile properties on the ribbon. We'll go this direction this time, or right click, go to profile properties this way. Also do it in tool space. And let's go to the design criteria tab. And now we got to use design check set, or excuse me, In this case, we check both of them. So we use criteria-based design, and then we got to use this one. This is going to a standard AASHTO. We talked about AASHTO before. We're looking for minimal K values. Remember, that's the sharpness, the ratio, the drasticness of the curve. A smaller K value is a tighter little curve. That's almost like two lines hitting. A bigger K value is a more gradual curve. And we're going to pick in here. Let's see what we got. We're going to pick this dot, dot, dot. And we're going to pick, instead of, we even have a newer one here, we have a few design standards. We're going to pick the Autodesk, in this case the book wants it, Civil 3D Imperial 2011 roadway design. And we'll hit open. So we changed it a little bit, the updated AASHTO standards. Make sure this is not selected, because we don't want, this will override it, our subdivision ones. This is our custom ones for our municipalities. We want to use this overall national standard. Let's hit, in this case, OK. Let the design criteria file, the XML file, would do its job. To check things, it found 3 things. So let's hover our cursor over the warning symbol to the lowest of the profile, which is here. Remember, the elevation of a profile is in the Y direction. So this is the lowest spot. Let's hover on it. It says minimum K for heading for headlight sight distance violated. So the minimum K value of this curve, so the headlights can see enough basically. So this current is 25 and some change. You see the minimum needs to be 26. So the K value is a little too sharp for headlight sight distance. Just have safe driving for your headlights. Okay. Well, let's go to the geometry editor. Let's go a little deeper in this one. Let's right click and say either edit profile geometry. We have it selected. Remember, profiles selected here. You can tell by properties it is the only thing selected. We just went to design criteria editor. We can also get to it this way. Another FYI. Let's go to, we want to edit, excuse me, we're wanting to edit geometry in this case. So do that. And I'm going to open up my, instead of my profile layout parameters, I'm going to open up the grid view, which I use probably more often anyway. It also shows where our warnings are. If you hover on them, they will say what they are as well as they do in the plan view. That is really cool. So you can really see in bold quickly what is wrong. So in this case, it tells us what's wrong. If we hover on it, okay. This is the one I was on right here. So I hover on this, it says, let's hover by the triangle. It says what is the K value that is in violation and what is minimum. It says 26. So I go to this and I'm going to change this to 26. It will fix it. Okay, that's the minimum. That one's good. So let's go to the other ones. Honestly, item 5 is good. 6. Item 7. This, so let's hover on this. Okay. K value is a little tight. So in this one, let's change this to 225, which should generate a K value of a little higher. I've expanded this out a little bit. I'm not going to fight this too much on this graphical editing, but let's give it a go again. It says on this one, item 6, I'm going to do exactly what it's told, 225. Could not solve. I think I might have changed one out of order is all. Order can be important on these. So I went back one step. Let me try this again. 225. Okay. I should have done that first. I edited this one by accident first, which is easy enough to do. I edited this one, which is starting to fix the one after. So if you pick on each one of these, let's zoom out a little bit. It helps you see graphically if you zoom out a little bit. You start going along these, it shows you which curve you're on, like so. Okay, that helps a lot to go hand in hand between graphic in tabular data. So we've been fixing some of these. It doesn't have us fix all of these. We could probably say just start playing with some of these and fix them. Sometimes they can't be solved mathematically because they're too tight for whatever reason. They need to be changed on both ends of the curve on different sides. So sometimes you need to dig into these a little bit. This one here, this PVI, possibly needs to be lengthened in a different direction. So we hover on this one. K value is still too small. And there potentially isn't any fixing something. Sometimes you got to start again. But we fixed the two we were meant to. So that is the end of chapter 9. K value basically is a way of expressing the abruptness, is another way to say, of the vertical curve. So you don't want to catch air with how abrupt it is. You want a gentle vertical curve for certain speeds. The higher the K value factor ratio, the gentler and generally safer the vertical curve on a highway is. So that's pretty critical to know. The couple other ones that came up is headlight distance and sight distance. So headlight sight distance is a whole term, is important as a design parameter for all road designs. So the peaks, the crests, and the valleys, the sags of a road, don't allow headlights to illuminate obstacles within, say, a certain acceptable distance. Then the road can be considered unsafe because headlights aren't illuminating as you go over these peaks or crests and these sags, these valleys, so you don't get good illumination as you drive your transportation or your vehicle. So that's a major thing. There's a certain acceptable distance that varies. It varies based on the design speed. So if you're going faster, that's more critical than slow. All of it comes to do with design speed on headlight sight distance and safety enough for the driver to react. So those all come into play along with the K value, the vertical abruptness of the curve. Those two are big factors in highway design. That is the end of chapter 7. We'll continue on chapter 8 soon.